Hey everybody, this is Larry. This is me going Q4 of the weekly contest 341. Minimize the total price of trips. Hit the like button and subscribe and join me on Discord. Let me know what you think about this problem. This problem, to be honest, is the only one, or the one that I feel like I read correctly in this contest off the bat. I knew what I needed to do, but it took me a little bit time just typing it out, to be honest. I think the trickiest part was just typing it out. I don't think I was at this part of the contest. I always screwed up with two problems. One with a penalty, the other I was just slow. So I was like, yeah, okay, let's let's at least give this a shot, or like let me just be careful is what I mean. And I think what I realized in the thing that made it hard, because actually the initial reading was that I thought that there'd be a weight on the edge and it's just shortest path with nodes or something. I don't know, but then I was like, okay, before this is also way long, by the way. But before your first trip, you could have some non-adjacent nodes and half the prices. So then the observation for me was thinking about, okay, if we have that, then what are we thinking of, right? Well, I was like, well, in a greedy kind of way, the thing you would do is have the prices after counting, like the number of times each node get visited. So I was like, oh, okay. So basically what you would do, what I did was that I was like, okay, so let's, well, the next thing I did was look at constraints. The number seems pretty small all around. There are only 100 trips, there are only 50. So, and you'll see me during the live part where I even said this out loud. 100 trips times n squared for like a BFS, it's going to be 250,000. So that's fast enough. And everything else is linear, so it should be okay. So that's basically my logic, was that, okay, so for every trip in that case, I do a BFS and I calculate how many times each node gets visited. I aggregated all the nodes together because you only need the sum. So then after that, we go, okay, let's do a dynamic programming on the tree, knowing what the rate is for each node. The rate, of course, is you go to the price of that node times the number of times you go to that node, right? And of course, with the option of doing this non-adjacent dynamic programming thing of having some nodes and not having some nodes. So that's basically the idea. So let's go over the code really quickly. This is just basic stuff. So the count is number of times this, or counts of ith node is visited. Yeah. Right. So yeah, and then we set up the adjacency list. We do a calculation, what I go calculate, but basically this is just breadth first search with path reconstruction. This is very standard breadth first search, and I actually took some time debugging here because for some reason, even though I've written this 1,000 times, I wrote this by accident, and that was no bueno. I had to debug it. You could watch it live during the contest, and that also slows it down a little bit. But I set up the path reconstruction, which is actually kind of useful because I think we did it on a daily problem, or maybe the weekly problem, very recently. Like either yesterday or the day before. You can check me on that one. But in any case, so I just wrote the path reconstruction. And just basically doing, visiting each node once and incrementing them, right? So that's up to here. That's the calculate function. And of course, for each trip, we do a calculate on that trip going from start to finish. And note that because this is a tree, the shortest path is going to be a unique path, and that's without revisiting nodes and stuff, right? So yeah. And then after that, it becomes, I forget, I think it's called like rob the house or something like this on Leetcode. Someone could leave a comment about what the actual problem is. But basically, you want to like do adjacent nodes, but not adjacent nodes. And then you have this DP. This dynamic programming has come up a few times before. So I'll go over it very briefly. The state is such that you have the node and the parent. And this is just a pair because, so that you don't go up the chain by accident. it's just, but you look at each node once, basically, is the idea here. So as a pair, this looks at each node once, and so this is O of n, and used is true or false, so there's only 2. So really, there are only 100 possible inputs. So this is pretty good to memorize, and we use some memorization. And the idea here is that if the last node was used, meaning the parent was used, let me write it out then. Okay, oops. So node, current node, parent of the current node, used, if the special power, I forget what they call it, halving power, maybe special halving power was used by the parent, right? So basically that's all that is. And because this is a tree, we don't have to do any funky things. We don't have to care about root, which one is it rooted and stuff like that. Please. Yeah, sorry. People in my Discord, it's talking about contests. I got confused, but yeah. Anyway, so yeah, so if the parent power was used, then, yeah, either way, either if the parent is used or not used, we can always just not use this. So this is the not used chunk. If we don't use the halving power, then you have this chunk that basically is, you recursively goes there to the children, telling them that the parent is not used, and then not use the power, and this is the price, this is the rate that we set, and you sum it all up, and you compare it to the best score. If, however, the parent was not used, then you can use the halving power here. Note that this is really just the same as this, except for one critical part, the pricing function, we half it, and of course, when we go to the recursion, we tell them that, look, it's true. Yeah, like the parent is used, so that you cannot use it the next time. So that's basically it. This is the DP. If you're a little bit confused about it, draw it out. But I also think there's a couple of dynamic programming, or a couple of these problems in Leetcode. So definitely someone link below, or ask me in the comments, and I'll remind it, or something like this afterwards. But yeah. So this part for each trip. So there are O of t trips. Each one is going to be O of v square, or technically O of v plus y, but in this case, because it's a tree, wait, is it O v? Oh yeah, I guess it's v plus y. So maybe not even v square, I lied. Because y is v, because this is a tree, so this is O of v. So this is going to be O of t times v for getting this count rate. And then here is just linear, right? Because basically, like we said, node plus parent is linear. There's going to be O of n, and used as binary, so this is also O of n in total. So this is going to be O of t times v is what it gets dominated by in time. And in terms of space, you have O of v, which is n, for the count. The edge list as well, as we said, this is going to be, this is a tree, so this is only v minus 1 number of edges. O of n here, but it doesn't go higher than that. And this is O of n, so I say O of n and O of v interchangeably. So yeah, so this is your final complexity for that one. Yeah, so now I'm going to show you I'm going to make it slightly smaller. I'll show you the top if you want to read it, and then the bottom if you want to read it. So yeah. That's all I have for this one. Let me know. Oh, excuse me. Let me know what you think. And yeah, you can watch me solve it live in the contest now. How far behind my 1,500? A couple of people got it pretty quickly. I should have gotten this one quickly. This one too, but okay, let's focus on the problem. Oh no, it's another tree problem. Undirected unrooted tree. Enter 1, integers n, and 2 the integer. Each node has a price. Given price of I, the price sum of the node. Okay. Given 2 array trips, where trips of I is equal to start I. Okay, and travel to the node I. You can, before, oh my god, so many things. First, you can choose some non-adjacent nodes and half the price. Okay, so you have these trips, and you could have the price of nodes. Five people got this already? 12 people got this already? What's constraints? 50. Price is 1,000, so maybe there's some DP. 100 trips. This is gonna be a yikes contest. Man, this is already hard enough, not even, well, actually, I guess without the halving, it's not that bad. Just all pairs, shortest path. There's 50 nodes, so you can't really do brute force, really. But it is a tree. Does it always make sense to be greedy? No, because you can have, if you have 4 nodes, you can maybe choose the roots, so it really oh, I see. So there, now you have to choose the number of times you visit and then do a DP on the, okay, I could see that, and do a DP on the nodes. Okay, I think I got it. People got it very quickly though, so I guess I'm not surprised now that I think I know the answer. But there's 100 trips, 50 square for DFS or BFS. So what's 50 square is 2,500. Wait, times 100 is a 20. Okay, should be okay, but if not, we're just gonna C++. All right, people are already done. This is ridiculous, but okay. Okay. Haven't even started yet, but I spent a long time on the other one, so it's not quite the same. Okay. And then for start and end in trips, calculate SV. And this is something that I actually expect other people to have things for it, so I don't think it's that bad, but still, we're doing the shortest path, right? Well, I mean, I guess it's the shortest path, otherwise it'd always be a little bit more. Okay. This is not right at all. That would have been taking me time to do it. Whatever. It's a little bit slower, but okay. Okay, let's just return 5 for now. Okay, so you have, that's not good. That's not good. And run this code like 1,000 times, you could still make a typo. It's a little bit sad. What? Because of this thing. Okay, so on the first, okay, I don't need to print this. So that means we visit node 3 times and twice, is that right? 0 to 3. It's not quite right. Have another thing. That's not quite right. So 0, 1, 1. So the first trip is from 0 to 3. 0 to 3. So that's 0, 1, 2. Right. Oh, it because count of start. Okay. A lot of potential typos. Okay, so from 0 to 3. 0 to 3. 2 to 1. And then 2 to 3. So it should be something like. Yeah, that sounds right, except for we don't hit. Oh no, 2 is this one. I'm looking at me. So 2 to 1 and 2 to 3. That looks roughly right. Okay, so then now we could do a DP on it. How many people gotten it so far? A lot of people gotten it so far. 832nd with a silly 5-minute penalty even, so that's gonna harm me still. Trips. Oh yeah, this is now just DP, right? So yeah, with node oh min, yeah, min. Okay. No, this is, well, this is just return false, I think. Because then now I could tell, okay, so if used, or if not used, then we could choose to use this, right? If we choose to use this, then not used, then we can choose to use this. If we use this, then we have, what's it called, price of node. What does halving mean? Are they all even numbers? Okay, so it's even. So we can halve this number times count sub node. Right, so this is the score, and then we can do a recursion on for each node. So we in E of node. So we sum that with go of we. Oh, because I did it with breadth first search that time. So I need a parent. Node, if b is not equal to node, a is not equal to parent. So used is true, right? Okay, and then best is equal to min of best score. Return best. Otherwise, the other thing we can do is not use it. So score is equal to price of node times count of node for v and y of node. If v is not equal to parent, add the score. So this is forced now. And best is equal to min best score. Okay. I thought I didn't. Oh, I put it inside the calculate. Okay, fine. 23 and 1. YOLO. Submit. That one wasn't that bad. Yeah, thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think. Stay good, stay healthy, take good mental health. I'll see you later and take care. Bye bye.